Dinosaurs lived a long time ago, at least until that whole mass extinction event. But how did they deal with the heat? Now, some scientists think dinosaurs were hot-blooded like mammals and birds are today. Others think they were cold-blooded like reptiles are today. And still others say it's not that simple. So, to get to the bottom of this, let's start at the beginning. First, we need to define our terms. What does it mean to be cold or hot? Well, it's really more accurate to call them cold-blooded or warm, because being hot-blooded implies that you can actively control your body temperature, which all vertebrates can do to a certain extent. We also do on one to use the terms warm and cold, because we do on one to imply anything about the actual temperatures these animals were operating at. Instead, we can describe them as either ectotherms rely mainly on external sources of heat to regulate their body temperature, while endotherms generate heat internally. For example, most reptiles they often sunbathe to warm up and will seek shade or shelter if they get too hot. Birds and mammals are generally you've probably seen a bird fluff its feathers when it is cold out or pant when it is getting too warm. These behaviors help them maintain a stable internal temperature. Now, this is a very simplified explanation, but one way that endothermy works is through metabolic rate. If an animal has a high metabolic rate, it generates a lot of heat, and that helps it maintain a higher, more consistent body temperature. Ectotherms have lower metabolic rates, and since they don't produce as much heat internally, their body temperature fluctuates more depending on what's going on in their environment. And we actually have evidence for both high and low metabolic rates in dinosaurs, making things more complicated. But before we get into that, let's talk about another important distinction. This describes animals whose body temperatures fluctuate over their lifetime. Maybe you know of an animal that seems to fit this description. Hi, I'm here with me. In my free time, I like to play with dragons, but I'm having trouble choosing one because there are so many cool options. Oh my gosh, look at this guy. He breathes ice. That would come in handy during the summer. Or maybe this one. She breathes fire. That would be useful during the winter. Wait, do dragons breathe different elements based on their body temperature? Is that why sometimes they feel hot and cold to the touch? I don't know, do you know? Okay, back to dinosaurs. As far as we can tell, birds are the only dinosaurs alive today. And birds exhibit some species maintain a stable body temperature year-round, while others allow their body temperature to fluctuate seasonally. So it's possible that dinosaurs in general were heterothermic, but there's more. Some dinosaurs were probably more heterothermic than others. See, even within groups of warm and cold-blooded animals, there's a range of adaptations. For instance, some fish are more dependent on the sun for warmth than others. Similarly, some dinosaurs could better regulate their body temperature internally. That means some may have been able to maintain a fairly constant temperature while others' temperatures fluctuated more. Okay, so we have multiple ways of classifying these animals, but where do dinosaurs fit in? To answer that question, we can look at the fossil record for clues. The first step in this process is to find a good sample. Since behavior is usually preserved in trace fossils like footprints and burrows, paleontologists search for fossils that preserve marks left behind by skin. These include impressions of scales, feathers, or other epidermal features. That S, because the type of skin an animal had, tells us something about how it regulated its body temperature. C, scales are associated with ectothermy. When animals are covered in scales, it means they were probably relying on external sources of heat. Feathers and fur, on the other hand, are associated with endothermy. That's because they help animals retain heat. But just as with modern animals, not all dinosaurs had feathers. Many species known from the fossil record only had scales, such as Ankylosaurus. However, more recent discoveries suggest that feathers might have been more common among dinosaurs than previously thought. A study published in 2020 used a variety of techniques to examine more than 1,000 fossil specimens. It concluded that nearly half of all dinosaur species had feathers, even fully aquatic dinosaurs. Now, that doesn't mean that all dinosaurs were having feathers is just one factor among many that contribute to our understanding of how dinosaurs regulated their body temperature, but it's a big factor. After all, feathers are associated with endothermy, but they aren't always present. So if we find dinosaur fossils with feather impressions, that tells us something. But what about dinosaurs without feathers? Well, even those fossils can tell us about body temperature. It turns out that the shape of scales can give us clues about whether an animal was ectothermic or endothermic. Many endothermic animals, including birds and mammals, have hair or feathers, which obviously isn't preserved in the fossil record. But some endotherms like turtles have scales. So to distinguish between warm and cold-blooded dinosaurs, some paleontologists focus on the shape of the dinosaur's scales. Specifically, they look for beta-type scales. These are small scales with pointed rear ends that overlap each other and fit closely together. That gives the skin a smooth appearance, which is useful for streamlining and water retention. Beta-type scales are found in modern birds, turtles, and crocodilians, but not in any other living reptiles. Why? Well, beta-type scales are thought to be associated with That's because the raised rear ends provide space for air to circulate, and that helps warm-blooded animals dissipate heat. In contrast, Most modern reptiles have rounded or squarish scales that don't overlap. These scale shapes are associated with being cold-blooded because they allow water to naturally evaporate off the skin, which can help cool the animal down. With that in mind, let's look at some dinosaur fossils. Fossils of Ornithomimus, Maiasaura, and Ceratosaurus have preserved scale impressions that indicate they were warm-blooded. The theropod Ceratosaurus had both feathered and scaled skin. Its belly was covered in beta-type scales, while the rest of its body had feathers. The armored dinosaur Borealopelta markmeachly had beta-type scales too. The researchers who described the fossils suggested that it was endothermic because of these scales. But they also said it could have been a kind of heterotherm that relied on behavioral thermoregulation when it was young and endothermic adults when it was old. So what about the rest? Well, beta-type scales have also been found in ornithischians like Triceratops and but these animals also had bony armor that likely insulated them, so it's hard to say if their body temperature fluctuated. Theropods like Tyrannosaurus rex and Velociraptor had large bodies with small limbs, which makes them seem like they were built for running. That's consistent with being endothermic because animals with high metabolic rates tend to be fast. But unfortunately, they didn't leave behind any preserved skin. So considering all the evidence, including bone structure, muscle attachment, scars, heart size, and even poop, some scientists hypothesize that theropods were endothermic, while others argue that they were. As you can see, there's no easy answer when it comes to dinosaurs and body temperature. Some were probably more cold-blooded, others more warm-blooded, and some were in the middle. So to get a clearer picture, we'll just have to keep digging up fossils and searching for answers. This video was made possible by a university and a grant from a national foundation. Their mission is to support scholars who are exploring fundamental questions about the origin, evolution, and distribution of life on Earth. Thanks for watching and learning with us.